In this video, we're looking at fluids. More specifically, we're looking at how density and buoyancy determine if an object will float or sink in a fluid. So first we have to define what is a fluid. And a fluid is a liquid or a gas that does not have a definite shape. In other words, it will take the same shape as the container it's in. If you have water and you pour the water from one glass into another, the water will take the same shape as the container it's in. Same thing for a gas. If we have a gas move from one container to another, it will expand so that it takes the same shape as the container. A solid is not like this. A solid will stay the same shape regardless of whether we put it in a new container or a new box. And we're going to look at why things float or sink in a fluid based on density and buoyancy. We're going to look at density first. And so our question for this is, how do we find the density of an object? Density is mass per unit volume. It is more conceptually a measurement of how close the atoms are together in a substance. So if I have something with a high density, that means that the particles are really close together. This would be something like gold or silver or platinum, something with a really high density. A low density, the particles are going to be spaced really far apart. This would be something like perhaps styrofoam, where the particles are really far apart from each other. You can think of it in terms of population density. A city with a high population density would be like New York. New York, the people are literally living on top of each other within the sky rises. The people are really close together, and when you walk through the city of New York, you're going to come across a lot of people bumping into each other. A city with a low population density would be like here in Lebanon, Pennsylvania. And in Lebanon, there's not quite as many people. They're more spread out, spaced far apart. You walk through the streets of Lebanon, and you are not going to come across very many people at any given moment. The equation for density is that d, the density, is the mass divided by the volume. It is the mass per unit volume. We have our circle equation over here. Again, d for density, m for mass, and v for volume. The units are either grams per milliliter or grams per cubic meter. They mean the same thing because a milliliter is the same thing as a cubic centimeter. The density of water is 1 gram per milliliter, or also 1 gram per cubic centimeter, since they mean the same thing. So the big part of this lesson here is to understand why things float or sink based on density. And so there should be a lot of review from maybe chemistry class last year, in that things sink when the density of the object is more than the density of the fluid. So for example, if I have something like aluminum, and aluminum has a density of 2.7 grams per milliliter, aluminum is going to sink in water because it has a density more than that of water. It has a density more than 1. Things will float in a fluid if the density is less than the density of the fluid. So if I have a type of wood, maybe poplar, and let's say that poplar has a density of about 0.8 grams per milliliter, that wood is going to float in water because it has a density less than 1, has a density less than the fluid. Now there is another way of defining or explaining why things float or sink, and that is through the buoyant force. So the second part of this lesson is we're going to look at buoyancy and how buoyancy determines whether things sink or float. So first we have the definition of buoyancy, and the buoyant force is defined as the upward force exerted by an object on a fluid. So the direction is that it is upward and is caused by a fluid. This is why when we go swimming in the pool or swimming in the ocean, things seem lighter in the ocean. They're easier to pick up. And the reason is because the ocean or the water helps lift the object for us. that buoyant force on the object helps us lift it. Now, the way we calculate the buoyant force is that it is equal to the gravitational force or weight of the displaced fluid. And so we're going to look at this statement here a little bit more in detail later on. But the idea here is that it's equal to the gravitational force or weight of the amount of fluid that is displaced by the object. Now, defining whether things will float or sink in a fluid using buoyant force, we have two forces acting on an object. We have the gravitational force and the buoyant force. Buoyant force is up and the gravitational force is down. If the gravitational force is larger, then the object will move down, it will sink. If we look at when the buoyant force is larger than the gravitational force, then the object will rise to the surface, kind of like a submarine or a bubble, or maybe a helium balloon rises through the fluid. If an object is floating, it turns out that the two are balancing each other out. If it's floating, it's not moving up or down. It is simply sitting at the surface. It's just resting there. An application of this would be something like the swim bladder within a fish. So what a fish can do is a fish can adjust how much water they displace by expanding or compressing a swim bladder within their body. If they expand their swim bladder, they increase their buoyant force, allowing them to rise up in the water. If they compress their swim bladder, then they decrease their buoyant force, therefore sinking within the water. And if they adjust it just right, they can make themselves just float, neither sinking nor rising within the water. A submarine can do the same thing, but a submarine cannot expand or compress itself. Instead, what a submarine will do is a submarine will adjust its gravitational force. If a submarine wants to sink, it sucks water in from the ocean. And by sucking in the water, it allows it then to increase its gravitational force and sink downward. If it wants to rise up, it reduces its gravitational force by pushing the water back into the ocean. And when it reduces its gravitational force, it will now have a larger buoyant force and rise up. And if it wants to simply hover part way, halfway from the ocean level to the floor, then it will just take in a certain amount of water just necessary to balance out the buoyant force. Now, the symbol for the buoyant force is the letter F. All forces are F. We've never deviated from that. We simply give a subscript. If it was gravitational force, it was a subscript of G. If it was a normal force, we gave a subscript of N. If it was a tension force, we gave a subscript of T. This time with the buoyant force, we simply give a subscript of B for buoyant. Unit of all forces are newtons. This is no different. Buoyant force is newtons. And our formula is right here. Now, to get this formula, we go back to that statement that we said the buoyant force is equal to the gravitational force of the displaced fluid. And so the mf is the mass of the displaced fluid, and then g is still 9.8 meters per second squared. Now, I want to just kind of talk about that a little bit more. And what do we mean by it is the mass of, or the gravitational force, of the displaced fluid. So let's say that we have a container filled to the very top with water, meaning one extra drop more will make this container overflow. And we place that container in a pan to catch any water that might overflow when we place an object in the container. Now we're going to take our object and we're going to place it in the container, making the water overflow into the pan. The idea here is if we take this overflowed water and we find its weight, that is the buoyant force. The buoyant force is the weight of this much water. Now, what I want to point out here is that the amount of water that overflows is the same as the volume of the object itself. This is how we typically find volume through a process called displacement. So the volume of the water that overflows is the same as the volume of the object itself, at least the part of the object that's underneath the surface of the water. So the buoyant force is the weight of this much water, which is the same as the weight of the same amount of water as the volume of the object. We refer to this idea as Archimedes' principle. Archimedes' principle says that the buoyant force is equal to the weight of the fluid it displaces. It is equal to the weight of that much fluid.